In this case, we're asked to find how many valence electrons are in Si2+. And another example I saw said how many valence electrons are in S-. So I wanted to do a positive ion and a negative ion. And there are multiple ways to do this. So the first, and probably arguably the easiest way, is to find out how many valence electrons are in the original atom. So in this case, Si2+, first find Si. So Si has 4 valence electrons. Si2 plus is going to have 2 less electrons, so 2 valence electrons. Said another way, Si2 plus will have the same electron configuration as magnesium, 2 less electrons, so it will have 2 valence electrons. Since it's 2 plus, it has 2 less electrons, so it has 2 valence, which would answer this question. For S minus, doing it the same way, if it's negatively charged, it would have 1 extra electron. So it's in 6a, so sulfur has 6 valence electrons. S minus would have the same electron configuration as chlorine, and it would have 7 valence electrons. So this has 7 valence electrons. Another way of thinking about this is that for silicon, the electron configuration is neon here in the noble gas in the group above, and then 3s2, 3p2, 3s2, 3p2. But if it loses 2 electrons, these 3p electrons go away, so the electron configuration of Si2 plus is neon 3s2, which has 2 valence electrons. If we look at sulfur first and then sulfur minus, it's again neon. So looking at just sulfur first, the electron configuration, 3s2, and then 3p, 1, 2, 3, 4, 3p4. However, when we add an electron to it, it becomes 3p5. To find the valence electrons, add all the electrons in n equals 3. So these 2s electrons and these 5p electrons for a total of 7 valence electrons. So either way you do this, you come to the same answer. Si2 plus has 2 valence electrons, and S minus has 7 valence electrons. I should also note that these aren't necessarily stable ions in all of these examples.